Hello all, let us discuss some of the common problems that will be seen while performing the signal integrity analysis, and as a project this might affect the performance because some of the decisions taken are based on the simulation results, right? So the signal integrity analysis plays a critical role. So let us look at some of the factors. The first factor is the model. The entire signal integrity analysis is based on the model. Basically, model represents the entire IC's characteristics, where, for example, if we take a IBIS model, IBIS model is basically the representation of the chip in its electrical form, right? Which helps in simulation, correct? So these the electrical specifications that are being part of that model, whether it be the kind of electrical levels, the kind of RLC parameters, so all these must be in line with the actual chip. So we know that the models are derived from the chip, but in some of the cases there'll be different variants of this chip, and we might be using a model which is different from the variant for which the model has been generated. So in that case, signal integrity engineer must have that knowledge to edit the model as per your requirement, and also use the proper voltage levels that are being used, and importantly, validate that model. So that is very very important. So before using it in the analysis, one has to validate the model. One of the primary things which signal integrity engineer miss is they do miss to validate the model. They directly download the model from the website and try to use it. Only after simulation or trying to simulate, they realize that something is wrong with the model. So in the workflow of the signal integrity engineer, validating the model is very very important, and getting the right model is the biggest challenge. And in some cases, there might be a scenario that model might not be provided by the manufacturer. This is commonly seen by the signal integrity engineer. So in that case, using the model editors, signal integrity engineers generate a model or replicate a model from other manufacturers' IBIS model and try to use it in the simulations. This actually doesn't give too much of confidence on the simulation, but there are some assumptions that are definitely required at that point with the simulations. So that is one more problem which is commonly seen. um, and second thing, when we are doing the signal integrity analysis, the SI engineers doesn't consider the power supply variations that might actually come when the final PCB and assembly is done and the board is actually powered up. So this scenario has to be covered by using some methods, else the actual performance of the interface will be different from what is seen in the essay analysis. So where to consider this is one of the challenge for the signal integrity engineer, and this is the biggest problem. So what happens is, SI engineer, based on the initial impedance requirements, might have used a specific stack up, and considered the impedance requirements, and provided all the inputs and performed analysis, and PCB layout engineer completed his job, and post analysis is also done. Now all this is done considering that whatever is considered in the PCB, whatever is considered um, as a stack up, is accurately done by the manufacturer. So there are cases, not there are cases, definitely there'll be impedance variations, and this will be mentioned by the manufacturer when he delivers the PCB or when he is giving the spec for which he is going to fabricate the PCB. So this consideration is not taken by most of the signal integrity simulations, and this will lead to a different conclusion with respect to simulations, and definitely there will be variations in the practical scenarios compared to the theoretical scenarios that we see. And another thing is component variations. This is the ultimate one. Now what happens is when a signal integrity analysis is done, engineers do suggest specific terminations as a output of that analysis. And they do consider that component and perform simulation and see that everything is fine, based on which recommendations are provided. Now, what is being used in the design, what tolerance is being used, and ultimately what component lands up on the board post the assembly is a big disconnect that will be seen in many cases. So the component variations must be considered by the signal integrity engineer, and when a specific example, when a specific series or parallel termination is suggested, it is important that the tolerance of that resistor is also suggested. Mostly the lowest tolerance resistor has to be used in the design, but it is with the signal integrity engineers to stress that and ensure that that is being used in the design. Else, the analysis would have been done considering zero tolerance, but actually the component might have that is used is having a 20% variance, and ultimately the practical and the theoretical signal integrity analysis change, and entire blame goes to this analysis, because with the same analysis it has given a different value. So this has to be taken into consideration, and a very very important parameter. So sweep analysis done in these cases helps to come up with the variations that are expected as an end product. And then PCB manufacturing variations. This is similar to what we have discussed. So, achieving the exact trace impedance is not at all possible. That's a ideal scenario. That's a dream, basically. So, we have to live with those variations, and PCB manufacturer quotes that. And gives those in their specifications. So that definitely is not considered as a part of the simulation, which actually is out of the hand of everyone in part of the project, because PCB manufacturing is definitely done by some other third party in 99% of the cases, and it is very very difficult to control. So ensuring that even that is covered in the simulation, and not just considering a single trace impedance value, doing the analysis for variation of those trace impedances is also important. So like this, there are several other things which the signal integrity engineer faces issues in his analysis. Please post if you have seen these scenarios. Please post if there are some corrections needed to what we have talked here, and post your experiences in the comments. Thank you.